Our next speaker is going to be Gisela De Rosa, who's going to talk to us about the Roman Research Nexus.
Yeah, here we go. Okay. Good morning, everyone. I know I am the last talk between you and coffee. I'm going to try to make it as painless as possible, believe me. My name is Gisela De Rosa, for people that don't know me. I'm the mission scientist at the Science Operations Center at Space Telescope Science Institute. I'd like to thank the organizers for inviting me over. This is not my community. I do variable objects. I work on AGN, reverberation mapping, but I've been learning a lot in the past day and a little bit. So thank you so much. This talk is a high-level presentation on yet another platform. And I know the frustration, but this one is built for Roman data. And believe it or not, Roman is going to launch very soon. So this is going to be an introduction of where the platform sits for transient study and how you can use it today to start developing your workflows. If you have questions, however, about policies, usage, stuff, everything is documented, but you can come reach out to me these days or submit a help desk question on the Roman help desk. All the work I'm going to present has been built in collaboration by SDSCI, but in collaboration with our partners, IPAC and Goddard. So this is really teamwork. I'm not going to spend a lot of time on this. I know you guys deal with tons of data, but this is the first time that we're dealing with a data volume problem for a flagship mission, right? So we're going to get 1.4 tera per day of compressed data. This is order of magnitude larger than what we have for GWST and HST. In addition to that, all the data will be public immediately. So we need a different analysis model. You're not going to be able to download all of your data on your laptop. And to support immediate public access, we need scalable shared infrastructure. So data compute and tools must be integrated. And so this is where the Roman Research Nexus sits. Now, if you've already heard about the Nexus and you already have an idea about what a platform does, I encourage you to use the next few minutes to actually log in on the Nexus. It's available right now at roman.sdsci.edu. If you have a MyST account, you just put in your MyST credential and you're going to be able to access your individual account. And so if you have already an idea of what the platform does, I encourage you to do that. And then I'll call your attention when I'm going to talk about what's coming next. Okay? Okay, for people that don't know the Nexus yet, don't check out. So what is the Nexus? Is a cloud-based science platform. All of the Roman data reduction, processing, and storage will be on AWS. So the Nexus lives on AWS and brings compute and tools to the data. In addition, it provides you with a pre-configured environment with all the Roman analysis tools that we are developing. And so you don't have to pip install everything or take care of having all the testing data sets. Everything is set up for you. Of course, you can also bring your own software, right? You can install your own software and build your own environment. We currently support end-to-end workflows from simulation to analysis, and it's built to be collaboratively. And we're going to talk more about it, but you have the opportunity to work as a team on the Nexus. Okay, before we move forward, I want to clarify one thing. There is one key misconception that's been going around that data will be hosted on the Nexus. That is not correct. The data will be archived in MUST and will be hosted on AWS East 1, okay? This will be all the data. It includes the SOC and SSD products, so images, stacks, catalogs, spectra, everything will be available there, and includes also the PIT products. So what Ben and Jacob talked about will also be hosted on MUST. The Nexus, what it does is to operate in the same AWS East 1. And so it brings your tools to the data. To give you an idea, latency is going to be very similar to you accessing files on your own laptop. And that's important where you are, working on millions of files. So where does the Nexus live? And for example, your world, like transient science work. Rapid generates the alerts, goes to brokers, goes to users, but then I imagine users will want to access the data, look at the images, download the files, run additional photometry. And so the way to do this is to access the data through mass, and then the Nexus is where the analysis workflows are executed. Now, accessing through mass doesn't mean that you need to go to the mass UI portal. You can easily go on the Nexus and programmatically query mass through things like Astro Query or using curl scripts, okay? Let's talk more about the collaboration aspect. So one thing that, from what I know, distinguishes the Nexus from other platforms, although things are evolving fast, is that we offer a team-based environment. If you log on, if you create a team, and you can create a team today, if you want to, there is a QR code on how to request a team. It's a simple form. I invite you to do it. If you create a team, you can have a shared file system already set up for you with all of your collaborators and shared resources. In addition, we also offer real-time collaboration options. So for example, if Ben and Jacob are working on a plot, but they're miles apart because Ben is attending a conference and they really want to work on this plot together, they can log on the same server, do real-time collaboration, work on the notebook, and finalize their plot like that. And all of this, of course, is being done to support distributed multi-institution teams, because we know Roman science will be done, a majority, by very large teams. Okay, what can you do today? As I said, we support end-to-end workflows that are meant to teach the users how to do basic things with Roman, how to simulate Roman images from A to Z, starting from level ones, your ramps, your exposure level calibrated data, your stacked images, how to analyze Roman data, how to search, mask, how to open these files, which are not in FITS format, before you're upset, in nasty format, but we teach you how to access it. We have data models to do it, and how to analyze it. We are implementing basic operations that we expect users to do, how to run photometry on your level twos, which are your exposure level data, how to measure galaxy shapes, how to create cutouts. By the way, for now, we're using AstroCut, but we are implementing a service for cutouts, which is the same service that is being developed for Fernex and is currently implemented for TAS. So there's a lot already there, and how the way these workflows are implemented is that we either teach you how to do it from A to Z, so you go through, sorry, wrong button here. Or not, here we go. You go through one of these workflows from top to bottom. Each of these steps is a tutorial, which is very implemented in a very pedagogical way. And it teaches you how to perform basic operations or use basic tools with Roman. So for example, how to run Roman Cal, the pattern, which is totally available, how to use Roman ISIM, how to use Pandaea or ATC calculator. So all of this is already available, but a lot more is coming. What about data? As I said, science data will be hosted in Must. Right now, we don't have science data. We do have simulated data sets. We teach users how to create their own simulated images using Roman ISIM, but we do include some of pre-obtained simulated data. One thing cool about Roman ISIM is that all the products are compatible with the pattern. They are in the right format. So you can exercise everything from the level 1 to the level 3, which are your stacked images. And so it enables testing workflows and building analysis pipeline. One thing that is coming up is that we have finally generated a set of simulated images that are like mini surveys, a mini implementation of the surveys. For example, for the galactic bulge time domain, we're simulating 8 days of observations in the survey. For the galactic time domain survey, we're simulating 5 square degrees for the full pilot and 90 days of the core component. So here, for example, if I manage here, you can see this is an image, simulated image of the bulge, just to give you an idea of how crowded it's actually going to be. So as I said, oh, by the way, sorry, these images are going to come up soon. This simulated data for the surveys, we need to build the infrastructure for you, basic infrastructure to be able to search through them and open them. But this will come up this spring. As I said, the Roman Research Nexus is in early access, which means that you can log on, you can request your team, and all the basic capabilities I talked about are already available, but the platform is actively evolving and there's a lot that is coming up. Now, if you're playing with the Nexus and you would like to listen to what is coming up, this is the time to pay attention. It's only 5 minutes. Okay, so here is a list of things. This is very selected examples of things that I think you might be interested in. But if you have questions, please reach out to me. I'm going to be here until Friday. So we are implementing new workflows. As I said, we have 3 basic workflows right now, but there are 2 more that are coming up by June. The first one is of high interest to you, I think. It's the simulation and analysis workflow for time domain data. So we show how to use Roman ISIM to simulate a transient based on whatever light curve and analyze, create cutouts, create light curve, and analyze it. This has been done in collaboration with the Supernova Pit, and we're working together to bring this and publish it by April. And then if you're interested more in the characteristics of WFI, there's gonna be a WFI detector characterization workflow where you can learn how to open reference files that are being created using real ground-based data from ground-based testing and learn about the basic characteristics of the instrument. So for example, the darks or the bad pixels that we're seeing, how do they evolve? Persistence is a thing that everyone is gonna ask me about. So there is gonna be a way to see what we have learned up to now. Things will clearly evolve as we transition to an orbit and we start commissioning and we start learning about how this instrument, how this telescope works in space. This is for the science functionalities, and then we have a lot that is coming up on infrastructure. Based on community feedback, we have decided to offer GPUs on the Nexus. This will be available, I know Rebecca is cheering, this will be available no later than science operations start, but hopefully much sooner than that. We're working on it. And right now, you can parallelize your workflows within your server. So what we're going to do to improve on that is to offer much larger servers for parallelization, up to hundreds of cores, that's order of magnitude, as well as we're working on implementing AWS native solutions for to support further parallel workflows. This is not a cluster. The Nexus is not going to substitute your high-performance computer. It's if you need to do work that it's about up to like 180,000 of CPU hours, you can do it on the Nexus. If you need to go beyond that, then there are other solutions that we're working on with the Project Science Office. We're also working on more options for data access and management. I don't want to go into the details, but we're implementing cheaper storage for the teams, and that's going to happen very soon. And also options to bulk upload and download files. This has been a huge request from the users, and so we're implementing so that you don't have to rzip your files in advance. You can just upload them. Okay, and now something else. This is not the work that I've highlighted and it's coming up. It's really just on the Nexus, but there is a lot of work that is happening to actually connect the archive and the Nexus and the analysis workflow. And this is something that MUST has been working on with us in the past several months. So as I said, Roman data are accessed through MUST. One way to do it through the Nexus is, use programmatically and query the archive programmatically. However, what about the opposite? What if you just want to select a bunch of sources on a color diagram that you obtain from MUST and then open them directly on the Nexus for analysis? And then from the Nexus, go back to a full sky viewer on MUST to do some more cross correlations. So this is what we have been working to enable a more seamless path from data discovery to analysis. So this is work that, as I said, is ongoing. Oh, this didn't start. There you go. We've been working, MUST has been creating a lot of new interfaces to support interactive data exploration and selection within the MUST UI interfaces, and then bring those directly into the analysis environment, which is the Nexus. So this will come up soon and will be available before Science Ops starts. Okay, there is one more thing that we talked about already, but clearly has some gaps, right? We just said that data collocation is important because it reduces the latency of your analysis. So if data are on AWS, you can always stream them. If they are on East1, it's gonna be faster. But what about data sets that are not on AWS and East1? A lot of science cases, including mine, including yours, need multi-wavelength coverage. And some external data sets are generally not collocated with the Roman data. So there is ongoing work on the MUST side to develop a cloud-hosted staging area and upload interface for contributors so that people will be able to bring their own data there. And there is a call out from MUST to identify key data sets that augment Roman science and to make sure that they're gonna be readily accessible within MUST, okay? That survey is ongoing and it's gonna close on March 31st, I think, in a couple of days, in a few days. So if you're interested in it, please submit your survey. And I'm gonna be done. Just to recap, the space where the Nexus sits is after your alerts, after the identification of your sources to do the analysis. Now, if we want to have the photometry service in there, I see no problem with that. So the Nexus is in early access. The more you use it, the more you let us know what's going wrong with it, what's going wrong with the documentation, what's not working, also what's working. Sometimes it's nice to have positive feedback. The best the product is gonna be for you at launch. So please use it, make it part of your development workflow. And I'm gonna stop here.
All right, thanks Gisela for the awesome talk on the Nexus. Anytime or quick questions for Gisela? Oh yes, if you have a Nexus account, that's pretty good. That's pretty good. And okay, now who had the question? Let's go to Osley first, and then we'll go to Dave, and then we'll go into the discussions.
Yeah, so one question I have is the I guess, workflow for reproducibility on a long-term scale? If I'm doing everything in the science platform, will I be able to access that in 10 years? If a project has been latent maybe for 5 or 7 years, does it go into some kind of storage? And what should I be doing to make sure that 10 or 15 years down the line, I can still reproduce the analysis that I did previously?
Yes, so the image of the Nexus, so whatever we deliver to the users gets updated periodically. You can imagine that, for example, we create a new version of the Roman Cal pipeline, right? And so after a period, we're going to deliver it. However, we are going to keep the past 2 to 3 images available for the user to use. With that being said, 5 to 15 years is a long term. And so everything will still be available to you, but you will need to update your scripts. That is the downside.
And maybe a final question from Dave, or yeah.
The Nexus looks great and it looks like it's getting better every day. My evil question is, how are we going to work with Ruben and Roman together?
That's a great question. With a lot of hurdles, the first one would be data access and not on the Roman side. But co-location of the data and stuff like that has been brought up multiple times. I don't know, Judy, if you want to say something from the project science office, if there is anything. Sorry to bring you in. I must say these are things that are being discussed at higher level. There are pilot projects for it, but to my knowledge, there's no final solution yet. That's what I can